In this video, we are going to look at the applications of AI in mechanical engineering industry. Normally, AI is seen to be more applicable to industries like banking and new age industries like e-commerce and fintech. However, mechanical industry being a core industry has huge opportunities to apply artificial intelligence. That's what we are going to see in this video. Let's start with demand planning. Demand planning is fundamental to any business and more so to the mechanical industry. Take the example of manufacturer of a car. Do you know that a car has hundreds and hundreds of parts in them? It could be any one of these parts and many more. So someone doing a demand planning exercise should do a demand planning at a part level and then roll it to the overall car. So demand planning is not just at the overall product level. And remember, there could be different types of car, different colors, different models, all catering to different segments. So the complexity of demand planning will only increase and not come down. So demand planning is a complex affair and it must factor in different ups and downs that are normally seen in the sales cycle. Imagine during holiday season, the sales of products like cars could peak and there will also be off seasons. So the manufacturer of the car and the demand planning team should factor in both the short term as well as the long term trends. All these things, the ups and downs, the trends and seasonality that we typically see are factored into demand planning. If you are doing demand planning for a simple product, you don't need sophisticated systems like AI. However, when the number of parts are more, when the number of SKUs or stock keeping units are more, as is the case, in the automobile industry, demand planning needs to be lot granular and a lot thorough, because a poorly done demand planning exercise will bring down the forecast accuracy. What is forecast accuracy? Let's say you expected 100 units of cars to be sold, but you actually sold 140 cars. So what is your forecast accuracy? It is only 60%, right? Because this excess 40 cars is contributing to forecast inaccuracy. On the other hand, if you sell only 60 cars out of the planned 100 cars, here also your accuracy is only 60%. Here you have excess and here you have shortfall. Both are not good for the business, because in the case of excess, you need to procure these many parts. You need to plan how you're going to manufacture, how you're going to store, how you're going to transport, how you're going to service. Here you have 40 cars that are lying in your inventory to be sold. Both are not good for the business. Both will impact the business in a negative way. We want forecast accuracy to be in the 90s, right? That is 90% plus. That's the kind of accuracy we want, so that everybody in the service delivery chain is able to play a role and keep the customers and stakeholders happy, because a happy customer always results in a strong business, right? There is also repeat business. A poor forecast accuracy hurts the organization, hurts the customer, and even hurts employee morale, because there is far too much crisis, far too many crises to be handled. So typically in the past, people were using Excel based tools. Even now many companies use Excel based tools, but complexities like the one that I discussed, right? where the number of SKUs are more, number of parts are more, right? There is too much fluctuation between months. There is long-term seasonality, long-term trend, short-term seasonality to be taken care. AI-based systems are better. Okay, Excel-based one is for simple business where you just have a single product, not much complexity. If you are a manufacturer of a complex product, multiple SKUs, right? Huge variation, in your business, go for AI-based systems. We have always seen that AI-based systems deliver a very good forecast accuracy. Excel-based systems typically operate at 60% forecast accuracy. AI-based systems are invariably above 85%. You may ask, can I come closer to 100? Well, you can, provided your data structures and data quality is really good. Okay, so when you start off, when you implement an AI system, you can definitely achieve 85% plus forecast accuracy in just about 3-4 months of implementing, right? So this is so much better compared to 60%, right? That's where many of the businesses are operating. And many companies, believe me, they don't even measure forecast accuracy, right? Forecast accuracy is very, very important. Okay, and what is behind forecast accuracy? It is robust demand planning. Okay, let's look at another example. Defect reduction. Let's say this is one of the components that go into manufacturing of the car, right? And let's say if you are the manufacturer, there could be cosmetic defects, or there could be structural defects, that could be measurement related defects. Any kind of defects can be there. How will you find the faults? Previously, people used to do physical verification. People also do, a sample test, right? Because it's humanly not possible to check each and everything. But today, this kind of check can be done using AI systems, right? And in particular, the image-based AI systems. Image AI systems leverage something known as deep learning. Deep learning is a more advanced form of machine learning that's particularly useful for processing images and unstructured data. So anything that comes out of the assembly line, right? The system checks, okay, this is the assembly line, right? The product comes out, the product comes out, the product is scanned, right? The image, which is nothing but the scan, right? The image is checked for defects by deep learning based AI systems. Isn't this wonderful? Right? It removes subjectivity, it removes bias, it removes boredom, experienced by employees, right? If the product is really small, right, it's very difficult to find defects through manual inspection, right? You need AI systems that can do this job very well. What if, let's say, a small component like this is a critical component in the end product? We definitely don't want defects in the product, right? So that's the benefit of AI systems. Because image-based AI systems, okay, have been growing in stature. The technology is developing. I'm sure the effectiveness of image systems will increase, manifold in the coming months. And manufacturing industry is already making use of this technology, but I expect more manufacturers to embrace this image analytics, image systems, so that defects, coming out of the assembly line, any type of defect for that matter, can be found easily, and maybe you remove that or take necessary corrective action. Okay, the next one is accident prevention. In mechanical industry, accidents do happen. Some of them, can be life-threatening also. Okay, there is only so much precaution an individual can take, and there is only so much oversight that can be had over your employees. That is where AI systems can address the challenges of manually monitoring, the movement of employees, the movement of vehicles, and the movement of
goods that typically happen, in a manufacturing area, right? How is that possible? It is possible due to AI systems, okay, that take the feed from CCTV cameras that are placed at strategic locations in the factory environment. So the CCTV images could be monitored, right, in real time by AI based systems, and necessary alerts. Maybe it's a message that plays out, over a loudspeaker, in the assembly area. It could be any kind of alert, right? So there's monitoring, right? Online monitoring, real time monitoring by AI systems. That's the advantage. Okay. This type of technology leverages, video analytics. Okay. Video AI, right? Video again is unstructured data. What is unstructured data? Images, PDFs, PDF documents, videos, MP4, these are all unstructured data. Okay. The structured data is like what you have in the form of Excel file, right? So traditional systems cannot handle these kind of real-time monitoring and playing alerts. So AI systems can monitor things in real time and definitely help in preventing accidents, especially the costly accidents, right? The next one is about warranty. Warranty is very important in mechanical industry. Warranty costs contribute significantly to the profit margin of any business. What do you mean by warranty? When a product like car or any other form of machinery is manufactured, the manufacturer expects a certain failure rate to happen, right? Let's say 100 cars were manufactured or 100 million cars were manufactured. Maybe the manufacturer budgets 0.5% of failure rate. In some industries it could be 0.1%, some other industry, it could be 1%. Okay, and this is based on the expected wear and tear and expected quality issues that are expected to flare up in real time use. Okay, whenever this expected failure rate is breached, that is, the failure becomes higher, it adversely affects the warranty cost that has been budgeted, and it adversely impacts the profitability of the business. So this failure rate has to be kept within the expected range. If there is a significant quality issue, obviously this failure rate will be breached. Okay. So what can really be controlled on the field and where AI can help? So that is the question that will arise in your mind. So there are three components to what is known as service quality that affects the failure rate. Product quality is important, and what is equally important is service quality. That is how well the service is handled by the dealers and partners. Okay, so in service quality, the important thing is what is known as no fault found. Let's say a car is down and the partner engineer replaces two parts. In reality, only one part should have been replaced, but two parts were replaced. So this additional second part, right, is actually a case of no fault found. Why should a part be replaced? That adds to the cost. That adds to the failure rate, right? This could be due to training or a case of fraud, right? An intentional fraud. The next one that I want to highlight is re-repair rate, right? This is also an element of service quality. A car comes up for repair, okay? A part is replaced. After a while, some other part undergoes a failure and the car breaks down. It's not due to any product quality issues, but the way in which the repair was done by the repair engineer. Again, this could be due to training or it could be due to fraud. So you see, service quality adversely impacts the failure rate and profit margin itself. In addition to this, there are different ways in which fraud can happen. Electronic components, the electronic data could even be tampered with, right? So no fault found, re-repair and fraud are important drivers of service quality, and they must be managed in real time. Excel-based systems are effective only to a limited extent. Why I'm referring to the Excel-based systems? Because many of the organizations still rely only on Excel-based systems to control the drivers of service quality. What can be done for this? You can use AI-based systems. AI-based systems has proven its mettle in predicting fraud, right? Not just preventing, but in predicting fraud, right? AI-based systems can identify anomalies in the data set, using which you can identify areas that need to be further probed, so that you drive improvements in the entire post-sales support area. So it's not just product quality that is important. Service quality is equally important for the organization. If left unchecked, you could end up with a higher failure rate, which obviously means a higher warranty cost and a lower profit, because warranty directly contributes to the profit margin of any business. As I said, some organizations are adopting AI-based systems, but many organizations still rely on Excel-based systems where factors are looked at in isolation. In AI systems, we study the factors and its interaction effects, right? Last but not the least, a very, very important one for mechanical industry, what is known as predictive maintenance. We all know about preventive maintenance, right? Let's say you drive a car, right? After driving certain number of kilometers or miles, or after a period of time like 6 months or 1 year, you will leave the car for preventive maintenance. But what if the manufacturer can say that your product is expected to experience some kind of problem next month, right? Based on the usage data that has been transferred to the manufacturer. That's very useful information for you, right? That's what predictive maintenance is all about. Predictive maintenance is about telling when your product is going to fail. It's not only from a consumer point of view, it's even from a manufacturer point of view. Let's say you have to manufacture a car. You will be using different kinds of complex equipments, right? As maintenance manager or as operations managers of those complex equipments, you would be interested in knowing when that machinery is going to fail, because when the machinery fails, your production is going to take a hit. When the production takes a hit, there is a financial component, right? There is a financial loss that needs to be managed. That's where AI-based predictive maintenance can really help. If you are using AI-based systems, you can move from preventive maintenance, right? In preventive maintenance, you can't predict future failures, right? If you're trying to predict future failures, it's only a guesswork. Whereas when you are using predictive maintenance based approaches, you are actually predicting failures. How are you doing that? You are doing that based on multiple metrics. Let's say, if you're talking of a complex system that manufacture cars, right? You can measure the pressure, vibration, speed, temperature, of those equipments. You can monitor these parameters in multiple dimensions. You can study the interaction effects. That is, you don't look at these dimensions in isolation and predict when a particular machinery is going to fail or when a particular component in a machinery is going to fail. That's wealth of information, right? If you know that a particular machinery is going to fail, you will definitely take action. That is possible thanks to predictive maintenance. You no longer rely on preventive maintenance, right? Of course, you can continue doing preventive maintenance, right? You can use other forms of maintenance or other forms of detecting defects like non-destructive testing or statistical process control. but nothing like predictive maintenance, because predictive maintenance uses AI. Okay, it considers the interaction of different parameters like pressure, temperature, vibration, speed, and many other parameters. Let's say if your machinery is emitting 20 different types of data, an Excel based system cannot track these 20 metrics or factors, whereas an AI based system can easily track. That is the power of predictive maintenance. The predictive maintenance can save a lot of headache for the organization, because you know beforehand when something is going to fail. A lot of success has been seen in organizations using predictive maintenance. From a manufacturer perspective, the number of unplanned, unexpected defects or unexpected outages can come down by as much as 2/3, in the first year of implementing predictive maintenance, right? So that's a summary of the applications of AI in mechanical industry. If you're someone who likes to go into details of programming related to machine learning, please check out my course on machine learning that is available on Udemy. I have provided the link for that course in the description.